The basic idea of today is to let you know what is microMIM, because many customers have asked us what is microMIM versus conventional MIM. So therefore, we came up with this first theme that is often asked, and I hope you get some new and valuable information for you to bring back to your company. Basically, I will introduce our company first and then the technology. So many of you know us already for some time. And those of you who know long enough, we used to be called just Taisei Kogyo, which is here on this blue and white logo. So we exist from the 1970s. And back then, we used to do plastic injection molding manufacturing. In the 1990s, we expanded to the MIM production. And then we are now focusing on MIM production as OEM manufacturer. Now, microMIM Japan was established as a parent company of Taisei Kogyo in 2017. And microMIM focuses on sales and marketing as well as R&D. So Taisei Kogyo is focusing on manufacturing side. Our headquarters, the plant, the research lab are all located in Osaka Prefecture in Japan. What we do is, as I said, MIM production, MIM components production, and some contracted analysis and measurement, which means that we do analysis and measurement of the parts that are not produced by us. When they are produced by us, of course, we do that as a part of our normal procedure for outgoing measurement and so on. Apart from that, we sometimes have also MIM feedstock sales. We are in the 3 countries. As you can see here in Thailand, Pathum Thani is north of Bangkok, between Bangkok and Ayutthaya. Then I am located in Offenburg, Germany, which is about 1 hour from Swiss border to the north on the ICE line, 20-30 minutes to French border. So we are about 60 persons in the group, which is a full-time employee. So there are other part-time people as well. Under Taisei Kogyo factory, we are certified with ISO 13485. The reason being that our main industry, which means 50 to 60% of our customers are in the medical device sector. This is why we switched from having 9001 to, well, we used to have 9001 and then 14001 together, and then we switched to 13485 in, I think it was 2019. Now, those of you who know MIM might be a bit boring with this slide, so I won't take too long. But basically, MIM is a powder metallurgy process. And first of all, we combine the metal powder, which is this, and binder. So the question is, which part do we do of this? We do buy them, and then we combine them, which is this kneading and pelletization process, and then make them into pellets. The pellets are, just like the plastic injection molding pellets, if you have seen, about the same size and same shape, which are now put into the injection molding machine. Then, when we make the parts, components like this, for example, we do not want any more of this binder inside, because at the end of the day, we want a metal part without any other material. Therefore, we put it in the debinding and sintering oven. In some other companies that produce MIM parts, they have the debinding furnace and sintering furnace separately. However, in our company, we do this as one step. So it's one furnace for those two processes. And debinding is sometimes called degreasing as well. So if you hear degreasing or debinding, it's basically the same thing. Now, this brown part is after the debinding, which in our case, we don't see at all. Then the sintered part, or in some cases, it's called silver part. This is the final metal part. Of course, in some cases, we might do some secondary process on top of this, but that's another topic to discuss. So you can see that it is shrinking. So from green part to sintered part, it's quite a bit of shrinkage. And this shrinkage rate varies depending on which metal powder and binder we combine, and particle size and so on. So this is, something that is different from material to material. Now, the product or technology overview. The microMIM that you know from our company is registered as our name, not here in Europe, but in Japan, is compared to the conventional MIM, a lot better in many areas. But we are naming these three because these are often asked by our customers. So with conventional MIM, you will get about plus minus 0.03 millimeter when the size or the dimension is 5 millimeter or less. But with our microMIM, you can expect plus minus 0.01 millimeter if we use the smallest powder size in stainless steel. So same with relative density. If you are talking about conventional MIM, this is just average, 95 to 98%. And with our MIM, 98.5 is minimum. We get a lot more than this often. And this is again the same. The base is the stainless steel smallest metal powder size. Wall thickness is another thing that is really often asked. So with the conventional MIM, it's about 0.3 millimeter partially. With our microMIM, we get 0.1 millimeter and less these days, depending on how long that section is and some other factors. But this has to be with a part that is 5 square millimeter or less. Then the surface roughness is another question that many people are really interested. So we are using this powder size, D50 223 micron, which is the smallest, and this will give you about RA.35 micron. Now, I'm going to move myself a little bit up here so you can see the whole chart. Now, the microMIM experienced material means the trials also included. So, not all are in serial production, is what we mean. As you can see, for the MIM sector, this is really wide range of material. Not so many MIM companies can offer so many different material. This is basically due to our R&D and the fact that we are making the material, i.e. the feedstock that I showed you in earlier slide. These are in-house. Therefore, we can control the material. We can create the material that is basically on your own, so to speak. But of course, there must be the powder that is ideal for MIM in terms of size and in terms of the shape and so on. Yeah, if this is not commercially available, we cannot, but if it is, we are open to do joint R&D with different customers to create different alloys or try new alloys. So if you have some ideas, you can come and talk to us about this. Now, the components that are here, some of you have seen them in real when we were able to meet in real, and after the COVID, we haven't been able to meet most of the customers. So for those who have not met us yet, we have prepared this so you get some idea of what kind of parts are possible. And I would like to mention that these are just some that we are allowed to show. So yeah, we are basically making a lot of medical device parts like this, the medical forceps. And these are just really some. And there are so many different varieties, but of course, being medical, we are not allowed to show most of them. So yeah, the forceps are one of the quite often manufactured by metal components. And this particular one is a disposable. So disposable, so after each operation of the patient, they are disposed. So others are permanent, so you can use for both type. Then we are making a lot of gears, as you can see around here. So some of the gears here are actually a bit large for us, but yeah, we have done them because usually they are not so easy to make, or they are quite expensive to make with other manufacturing technology for serial production. Now I'm gonna talk about this. This is a part that some of you have seen in real, but this is part that has inner curved structure with undercut. In order to make this, usually you cannot do this with conventional mold technology. So yeah, I will talk about it later. But we have a technology called 3D MIM that allows us to make such components. And this is another example. So this channel, this is actually cut. So we, cut it so that the inside will be showing. So if you see the real part, this is the surface you are going to see. And this is an internal channel. Now, another example that you might find interesting is the integration parts. We have, not often, but we have sometimes this kind of projects where the customers were making, these were machine parts and they were assembled. Then they came to us and said, can we solve this problem? The assembly costs too much and it takes a lot of time. And the producibility is not always so stable. Then we came up the idea to make them from that as one component from the beginning. Therefore, they cut the cost of the parts. Even if they have to invest in the mold, they cut the cost significantly and the lead time as well. So they were very happy. Now, this integrated wheel is to show this kind of very, very small size integrated wheel is also possible. So here is approximately 500 micron. And I think this is about 300 microns. So yeah, this kind of very small size is also feasible. And then the copper parts are here. These are pure coppers. Then other example is this is copper alloy called nickel silver. And then we do also have some other metals, but many are actually stainless steel parts. This is a soft magnetic material. Okay, so I would move to the next one. This is the set of this big gear, which is an integrated gear. As you can see, this and this in one ring, so to speak. And then you have another tiny helical gear here that is combined with this area. So you can see more clearly that it is quite nicely made without no visible parting line. So a lot of the medical device gears are helical gears because they are good for not making much noise. This is another helical, but this is internal helical gear. And as you can see, the helical is here, and then on the bottom is a lid. So it's very difficult if you want to manufacture these for serial production with other manufacturing technology. So for this kind of gears, it is ideal to use MIM technology. And for those who are not so familiar with MIM, these circles are the ejection pin marks that will appear somewhere on the parts. But of course, we can discuss beforehand, before the production or before the prototype, where you cannot have them. So they will not appear on the critical places, which you will be like, outer parts or some functional places of the component. This is a tiny nozzle that have a tip of a 30 micron hole here inside this. So this kind of nozzle can be applied to medical device as well as other industries. Perhaps some of you are wondering, but how can you make this with mold technology? Like you must be making this by secondary process. No, we are making this only with mold. And this is the topic that we will have for the next series of webinar. Now, the 3D MIM that I have talked about earlier is here. And first of all, this core, or we call it SP mold, sacrificial plastic mold, this is made in plastic department, basically, and then we overmold the metal. Then we have this in the furnace. So as I said, degreasing is same as debinding, taking out the binder. So in this degreasing or debinding and sintering step, we not only remove the binder, but also this core, this one. And then when it comes out of the furnace, you get just the metal, no binder inside anymore, and the structure like this inside this component. So we are making such components for mass production with hollow structure, or pipe component with undercut, or some component with microstructure. And this can be sometimes applied to outside of a very tiny part. So you have the external SB mold, and then inside there is a metal. So that's also possible. Now, the latest news is that some of you might have read that we are having this 3D metal printer this summer. And this is a very good news for those of you who are interested to do the prototype, but do not have the budget to invest in the prototype mold. So, as you can see here, if you are making smaller quantity, it often doesn't pay to invest in the mold, in the prototype phase. So by having this, we make the green part, which is the part that is after injection molding, with this machine. And then we put in the furnace for the binding and sintering. So basically, instead of making a prototype mold, put it into the injection molding machine and make the green parts, we use this machine to create the green parts. And after that, it's the same process. So you can evaluate your prototype parts for, 100 parts or 50 parts or 500 parts. And then you can do your design change when you move to the serial production. Then you can invest in the mold to go for mass production. Yeah, so this is excellent to have this opportunity. Thank you very much, and I wish you a very nice evening and continue to have a nice week.